All right, great. Hope my screen can be seen, right?
Yes.
Great, great. Okay, so thank you. Today we are going to look at something fascinating, all right, which is machine learning driven predictive analysis, right? So currently, it's like everyone is talking about AI, machine learning, and how best they can it's like integrate AI into their workflow so they attain best productivity or it's like increase productivity like at the end of the day, right? And what we have to like understand is there was like machine learning because of data, all right? And when you come to the petroleum it's like industry, the petroleum it's like industry is known to be one of the it's like industry that produce a lot of data, all right? So how best can we transform this data into confident $1 billion decision, right? And that's what we are going to look at today, all right? So at the end of this section, my goal for you guys is to see machine learning as a precision tool in your like engineering toolkit. Um, Yes, agenda for today. Basically, at the end of the this seminar, we are going to understand predictive analysis in petroleum, see how machine learning is applied in like oil and gas problems, work through some case study, and learn how prediction supports risk-aware decision. All right, okay. Uh, Before we continue, I would like to know how is the question and answers going to be done? Is it when I'm done with the section, then are we taking questions or uh, whilst I'm teaching, we can take in questions? Which one works best?
When you are done, you can take in the questions.
Right, right, right. Great, great, great. Okay, so why this matters? Why do we have to care about machine learning driven predictive analysis? So first, we are looking at high stakes decision making. When you come to the petroleum industry, what we have to understand is a small decision is really never small, right? One wrong drilling, it's like adjustments can cost millions of dollars, right? And what machine learning does is it's like it helps us to make a decision with like evidence, right? Not guesswork. So at the end of the day, the decision that you are going to make and will cost you, machine learning will help you to reduce that, all right? And second, we are talking about complex and nonlinear systems that we have, all right? So the subsystem is basically not a straight line problem, all right? So what that means is like increase in pressure by 10% does not necessarily means that production will just like increase by 10%. All right. So the relationship is really messy and nonlinear. And this is where machine learning does better than the normal it's like equations that we do have, right? So basically, machine learning yes, like is able to like handle complex behavior that we find it difficult to yes like handle, right? And third, we are talking about the yes like huge data. It's like as I said, when you come to the petroleum yes like industry, the petroleum industry is seen to be one of the it's like industry that produce a lot of data. We are talking about sensors running 24/7. We are talking about log data constantly yeah, yes, like updated. We are talking about SCADA data. We are talking about seismic data. And what you have to understand is machine learning does not get tired. Machine learning can process all this data and discover patterns and trends from the data that we would miss. All right. And third and fourth, we are talking about quantifying the like unknown. We are dealing with like unforeseen circumstances. Whatever that we do is more like projection. All right. What that means is we basically don't have full idea and what like happens like underground, right? What I'm talking about, rocks are property, fluid movement, and faults all have what? Yes, like uncertainty. So with this, machine learning help us to quantify this yes, like uncertainty so that we can make an informed risk-based decision. All right. So now the goal here is to move from like reactive physics to proactive like optimization. All right. So basically we react to problem after they yes like okay, all right, but the goal with machine learning is to predict issues before they yes like okay, all right. So with that, machine learning help us to spend less, lose less, and decide better, all right. So basically these are the main core values or reasons why we have to care about machine learning driven predictive analysis. Now let's look at machine learning before we can be able to get yes like everything done. We have to understand what I thought is machine learning, so that we can at least have the foundation on how things happens. All right. So, but before we dive into machine learning, I would like us to watch some 1 minute video so that we can get the foundation from there.
Machine learning, Bawa project.
Uh, can you hear the voice?
No,
Okay, let me join again.
Together, we came out with these pipeline bots. So in front here you see the camera, so the night vision camera. So what this camera does is that it helps us to take the images of the inside. So for instance, this pipe is 4 feet pipe, and then inside it you could see there are some demarcations showing the rusted parts and the non-rusted parts.
Okay, so basically, what you watched has to do with robots, right? So what this robot does is like it goes through the pipeline and dictates which parts is corroded, right? So basically, what I want us to uh, get get from here is the brain of the like robot, right? So basically, the robots just move, right? But what is powering it is the ability to dictate which part of the pipe is corroded, right? So and the what is powering that is machine learning, right? So basically, what we did was we collected a lot of data, right? Pictures that has to do with corroded pipelines and non-corroded pipelines, right? Pictures of them, right? Then we fed it to our system, right? So we train our systems to get the patterns of corroded pipeline and non-corroded pipeline. All right. So yes, like at the end of the day, when the like robot is moving and it dictates a corroded pipeline, you are going to get it on your phone, right? So that you can attend to it as soon as possible, right? So basically, this is core, yes, like application of machine learning in the petroleum, yes, like industry. But this has to do with like robotics and machine learning, right? And I wanted you guys to get the machine learning point of view, right? So now let's see what is machine learning. When we talk about machine learning, we are training systems to learn from data so that they can discover patterns and trends and make decisions, right? So basically, that's what machine learning is. And what we have to understand is machine learning is a subset of artificial intelligence, right? And under machine learning, we get deep learning, generative AI, and now what is trending now is generative, it's like AI. So when I say generative, it's like AI, what I mean is any system that generates new content, like our ChatGPT, right? It's Gen AI. When we take Claude is Gen AI. When we take Grok is Gen AI, right? They are all a generative, yes, like AI. But today we are not going to go into details on that tangent. We are just going to see machine learning, how we can use machine learning to make predictive, yes, like analysis. And the core, yes, like of it is to learn from data to discover patterns and trend. And at the end of the day, it can make a decision. Right. Okay, so it's just data plus like equations, then we get our future predictions, right? Now, what is predictive like analysis? So basically, it's just the result from that learning. So whatever that our model learns, the like outcome is predictive like analysis. All right, so let's take this case study. We have our pump, and we petroleum knows what this ESP does. It's basically for transportation. All right, so we have our pump, and we are taking data, vibration data, temperature, flow rates, pressure, current, and these are sensors. These sensors are running 247. All right. So this data is being collected, right? Then we ensure that whatever data that we are collecting is clean, right? Because we we as mankind, if we are consuming something, we ensure that whatever that we are consuming is clean, right? Same as machine learning models. Whatever data that we are feeding to the models, we have to ensure that they are clean, right? So processing is being done here. When that is done, we pass the clean data to the model, and this is where the training, yes, happens. This is where the learning takes place. This box, right? Okay. So after the training, and this model can be linear regression, random forests. We are going to look at them all, right? So for now, just yes, like understand that we are feeding the data to a model, something, right? And there's going to be a processes that will goes on. So the outcome of this is the predictive analysis, right? So this box is what we call the predictive analysis, right? Okay, so with a predictive, we can get failure probability. What that means is how likely is failure if we continue in the same target. We can get remaining like useful life. How many days is left before failure? We can get recommended yes, action. So all these are predictive analysis. And what we have to understand is predictive analysis does not comes with the decision. All right. So you has to come up with a, decision, right? Whatever the predictive yes like is telling you, you have to now get this and make your decision. Oh, let's say based on this, let's take this route. Based on these conditions, let's take this route. All right. So basically, this is predictive yes like analysis. Just this is the predictive analysis. Now we have types of machine learning, right? So one of them is supervised learning. What that means is learning from past experience with answers provided, right? So in other words, we train them a model with yes, like labeled data, right? So when I say label data, what that means is we have our what? It's like inputs and it's like outputs. All right. So whenever we have a data that has yes like inputs and yes like outputs, we say we are dealing with supervised learning. All right. So here, as we can see, we have yes like animals, pictures of animals. We have cow, camel, right? So they are being labeled, right? So what yes like happens here is when we feed this labeled data to our yes like equation, now it's we are going to get a supervisor that's will tell our model, okay, so if you see this kind of features, they are camel. If you see this kind of features, they are cow, right? So now our model will take this, yes, like and process it, all right? And at the end of the day, our model can tell us which one of them is cow, which one of them is camel, based on the training that we did, all right? So if we have this kind of data, we say we are dealing with supervised learning. Right. So let's in petroleum, for instance, let's assume we are predicting daily it's like oil production. Right. So the goal here is to get production, right? And we can see that the last column tells us that this is a supervised learning problem, right? Because we have yes, like conditions and they are yes, like outcome, how does the result yes, like is going to be, right? So at the end of the day, the model will learn them patterns and trend. Okay, so if we have high pressure, if we have low flow rates, we are getting low production. If we have high pressure and high flow rates, we are getting high production. All right. So at the end of the day, the model will learn all this pattern. So whenever we have well uh, conditions, the model can now predict the future production, right? So that we can make a decision based on the prediction. We can use that uh, predictions to make decisions, right? Okay. And second type has to do with like unsupervised learning. With this, we don't have like answers. We only have raw data. We don't know how the outputs will look like. It's only raw data, right? There's no supervision. So what the model does is the model goes through the data and discover patterns and trend by like itself, right? So this is where the grouping yes like happens. So basically here we don't have yes like labels here. It's just the raw pictures that we are trying to give it to our model, right? So now what the model will do is the model will try to learn the features of each picture. All right. So when the models learn the features of yes, like each picture, it will group them. It will group the pictures with similarities, right? With closer features, right? Yes, like it's going to group them in one group and other ones, yes, like in one group. So if yes, like it sees something of this sort, it's camel. If it sees something of this sort, it's cow. All right. So basically, that's how the training yes like is being done. If we are going with like, unsupervised learning. All right. So at the end of the day, we are going to get groupings. When we feed any picture, yes, like it's going to look at the features. Is this feature closer to yes, like camel? Is this feature closer to cow? So we are going to get yes, like all these stuffs. Now let's go into petroleum perspective, right? So now we have well data, right? So now we can see from the data, we don't have any section that tells us that, oh, this well is doing good, this well is doing bad, all right? So yes, like at the end of the day, the model has to come up with groupings, all right, tell tell us that, oh, when we see this kind of features, that means we have good work. If we see this kind of features, we have bad work, right? So then a model can learn something like, okay, so if we have high production, low flow rates, we can group them into let's say bad well, if we have high production, low flow rates, we can group them as good well. All right. So yes, like at the end of the day, the model will learn all these patterns and group them. All right. So as yes, as domain guy, you now have fair idea on which kind of well has problem, which kind of well, yes, like is good. So you focus on the well that are bad to maintain it so that you can get good production at the end of the day. All right. So this is it's like unsupervised learning. The last type has to do with reinforcement learning. Though this is not the last type, we have different types: semi-supervised, self-supervised. But these three are the core types of machine learning that we do have. This is reinforcement learning, and the learning is being done by try and error, right? So yes, like what happens is then our model will take several actions and observe the outcome, right? So as time goes on, then machine learning will learn that okay, good decision produce high like oil, bad decision produce low like oil, right? So at the end of the day, the machine will get all this what like idea, right? So that under these conditions, like if we take these actions, we are going to get high production. Yes, that's under this condition, if we take this like actions, we are going to have low production. All right. So with this, you can constantly do what? Yes, optimize strategies. So throughout the presentation, have been mentioning models. We have, yes, like a lot of models out there, machine learning models. And what you have to understand is they are all maths. Yes, they are all maths. And we are not going to go, yes, like into the maths perspective. We are just going to see the general words. Okay. So we are going to see the kind of models that we do have and how best we can like leverage on them to like get good results. All right. Yes. So we are not going to talk more about the formulas, how they work and stuff. So we are going to just get how like high view of them, and we take them like into practice. All right. Okay, so I didn't finish with this part. So let's come here. Uh, yes, we have, yes, like a lot of them. And what's, you have to understand is you can build this model from scratch by yourself using Python. And when you go to Python, Python has a library that we can fetch all these models from them and use. Right. So there are two ways. It's either you build it from scratch, you take it from Python library and just use it, right? That's where when you come to the field, for instance, we have machine learning, yes, like engineers, and we have, yes, like AI, yes, like engineers, right? So them machine learning engineers will build it from scratch, right? And yes, like the artificial guys will just take the model and just use it in their that's like applications, right? Okay, so These are the kind of models that we have. They are traditional models now because of large language models and stuffs. We call this traditional yes, models, right? So first we have linear regression, and this is the basic one of them. And I know we all have used this one before, way back GHS, senior high school. We've been plotting graph y is equal to mx plus c, right? That's linear. All right. So basically, what this model does is it finds the relationship with best fit line, right? That's all. So if you're able to get the best fit line at the end of the day, we can make any prediction, right? So if you can now recall back GHS senior high school, after drawing the straight line, they will give you values of x to find y. That's the prediction. Yes, like at that time you were doing like machine learning, but it seems you didn't know. All right, so this is linear regression, and it is the base one. It is simple, easy to use, and the next one has to do with rich lasso. So basically, this model.
Motorbike.
You can go
Okay,
ahead.
okay. So we have rich and lasso. So with this model, it's just like advance of linear, right? So sometimes what linear does is linear when the data is complex. Let's assume that we have a lot of relationship. Linear gets like confused, right? So they develop Rage and Lasso to solve that complexity, right? So that's Lasso. Uh, like as I said, we are not going to dive into the mathematics, aspects for today, right? We are just looking at how they work, all right? So we have a decision tree. So decision tree is more like like if else. So if this is this, do this, else do this. That's it. All right, it's decision tree. So like if the situation is this, take this route. If the situation is that, take this route. Right. So at the end of the day, we are going to get a full tree. We are going to get roots, branches, leaves. That's our decision tree. And next one, we have random forest. So random forest is combination of decision trees, right? So we have a lot of decision tree, and at the end of the day, we vote and take the best one, right? The one of them that is going to give us the best like result. So if like let's say this tree is giving us one, this tree is giving us two, this tree is giving us one, this tree is giving us one. That means one dominates. So the prediction is going to be one. That's how a random forest work. We're good. And then next one has to do with gradient boosting. Gradient boosting is sequential learning, right? So with random forest is power, right? So we are going to have learning from this tree. We are going to have learning from this tree, and at the end of the day, we vote and take the one that's like okay, it's good. But with gradients boosting, that's not being done there. It's sequential. So the tree one will learn first, and then pass it to tree 2, right? So whatever, yes, like errors that we are going to get it in tree 1, tree 2 will just correct it, right? The same way. Then yes, the chain will be moving. All right. And the next one, we have XGBoost. All right. So XGBoost is more like a gradient boosting, just that it makes it fast. Right. That's all. Like it makes gradient boosting fast. All right. Same as light GBM. All right. So it's more like, yes, like advance of like XGBoost. That one too, it makes the training and yes, like everything fast. And it's more like robust as compared to the rest. So basically, these are some of the models that we have, and we are going to see how best we can use them. They are so simple. So we can say that this linear regression, decision tree, they are all basic, all right? So advanced one, let's say gradient boosting, yes, like XGBoost and light GBM, they are what? Yes, advanced models. Very good. Let's go back to our slide. I hope we are learning. Okay, so now we've gotten to know machine learning, how machine learning works, and models. We've understood predictive, yes, like analysis. Now the workflow, how do we use machine learning to solve problem? How do we use machine learning to make predictive, yes, like that's like analysis. So, but basically, these are the workflow when you come to the yes, like industry. This is how we build yes, like models, right? First, we have to ensure that we have data. We have a lot of data. And second, we ensure that whatever data that we do get, we process it. We ensure that they are clean. We remove all noisy stuff from it and ensure that they are good to consume. All right. And the next one, we do the model selection and training. So as I showed it to you, we have a lot of models. Basically, what you have to understand is machine learning is it's like iterative process, right? So you don't do it just once and say yes, I'm done, right? You have to do it, yes, like iterate it. Basically, the reason why I'm saying that is model selection, right? So as I said, I made mention of yes, like a lot of models. So how do you know the best one? All right. How are you going to know which model should I use for this particular problem? Right. So you can have a problem that's yes, like random forest can solve the problem for you. You can have a problem that yes, like XGBoost can give you good yes result. Now, what you have to do is you have to try both of them and see which one yes like is giving you the best like results. All right. So that's why here we have model selection and training. Right. So here it's more like yes, like that's like iterative. You are going to do it over and over so you get the best one, right? And the next one after the training, we yes, like evaluate it, right? We check that whatever that we've trained, yes, like is it giving us good results, right? And the last one after the training, we have to make decisions, right? That's where we deploy it into real life to make predictions and take decisions. All right. So basically, this is the workflow when you come to the like industry. This is how we take to solve a machine learning problem or build machine learning models. All right. Okay. So now that we've seen how to build machine learning models. Now let's take a case study. Let's go into a Jupyter notebook so that we can take a simple solution and see how best we train our models. And don't worry if the codes are scaring you or something. Just I just want to show you how training is done right in rare scenario or when like you come to the just like that's like industry, the steps that we take to build models, use machine learning to do predictive yes, like analysis and code. All right, yes. So I don't know which one worked best for you. I can share the notebook for you, anyone that want to follow or something of that sort. Uh, which one worked best for you? Or I should just go through.
Malik, you can drop the link in the chat box. So whoever wants to go through it, you can use it.
Okay, right. Great. Okay, so I've sent the link to the chat. I made it comprehensive so that everyone can follow, or even if you are not a programmer or you've never touched code before. I've make it comprehensive. Right. So we are taking one data from cargo, right? So this is Volve production data, all right? So let's know, sorry, yes. Okay, so this is a fraud that was discovered in 1993, right? And the fraud, yes, like had a production from 2008 to 2016. That means, yes, like 8.5 years of production that went on. So that means we are going to have a lot of data, right, at the end of the day. Right. And so basically, this is some information about the data. This is the data. When you go to Cargo, you can get this data from there. Right. The petroleum students, you can go there and let's say take it and try your hands. All right. Okay. So before we continue, I made mention that in Python, we have, yes, like libraries, right? So that's why when you come to the machine learning and data space. Python is widely used for those stuffs. Why? Because Python has made certain things easy, right? We don't have to do like everything from scratch. We just have to just like call them and use. That's libraries, right? So we first get our like libraries, and most of the libraries that we are going to use is pandas, right? So pandas will help us to read our data, clean our data, and we have a NumPy. All the mathematics stuffs, NumPy will handle it, right? And we have matplotlib, right? So matplotlib, the graphs that we are going to plot is going to be done with a matplotlib. Seaborn is the same thing. It's advance of a matplotlib, right? And now we have a like library called scikit-learn, right? So with this scikit-learn, that's where we are going to get all the models that we made mention of it, right? So we don't have to code it from scratch or do it from scratch. We are going to get all these models from scikit-learn, all right? So the models that we are going to use, random forest, linear like regression, decision tree, XGBoost, all right? Yes. So we have to first, like get all the tools that we are going to use. Yes, everything. So second section has to do with data collection, right? So we have to load our data and and clean it, right? So basically, what I did here is I didn't load the data from here straight, right? I duplicated it, right? I hard coded it, right? So because I was going to share the link for you guys, I didn't want a situation that I would download the data, then we have to transport the data or transfer the data for you guys, right? So here I just generated the data, the same data that we are going to get here. I generated it, sorry. I use code to generate all the data. So basically, this is our data generation. We've gotten our data. Let's see our data. So as we can see, the data that we do have, it ranges from 2008 to 2016 data. And the number of wells that we are looking at is 7, right? And the total of the records is 8,000. Right. And these are the wells, like ID, right? So each well has an ID to identify that this is well one, well two, well three, right? And these are the columns that we do have. We have wellbore code, wellbore name, so on and so forth. All right. Okay. So now let's view the first 5 data. Okay, so basically, this is our data. This is the data that, this is the bottom of the data, the last one, that's 7,999. If you want to get to see the head, the start, right, we have, right, yes, so this is the starting zero. So any amount of data that you want to see, you just type in here, then you can see any amount of data that you want to see from this data. Let's say you want to see 20, right? So we are getting 20. Right. Okay. So now we've gotten our data. We've gotten our data. Now, as I said, we have to clean the data. We have to prepare the data, ensure that the data is clean. And that's what we are doing here. All right. So if you can see, uh, some of the wells were not producing, yes, like oil, right? So they were producing water, right? And the goal here is to predict daily production, right? So we don't need water production. So what we are doing here is we are taking the wells that are giving us water, all right? So let's see. Okay, so flow kind, yes, production. Okay, so let's see. Till I saw it. I want to show you the thing. Okay, yes. So we are just taking off, yes, like any rule that has nothing to do with production. You see that this one has nothing to do with production. So we have to clear it. That's what we are going to do here. And also we are going to check missing values, right? So do we have any missing values? Right. And we are going to see zero production days. We are going to check if there was a day that we didn't get some production. Right. Okay, so after the filtration, after we remove all data that has nothing to do with production, we are getting 7,361 data records. We don't have any missing values. Records are positive, all of them are positive, all of them there's a production, right? Every day we are getting production, right? So now let's check the summary of the data. This is most important part, the statistical approach, right? So basically, whatever that we are seeing here is telling us something, right? So the count here is telling us the amount of data that we have, right? So in machine learning, data really plays an important role in machine learning processes, right? So as I said, there is machine learning, there's AI because of data. All right. So we have to ensure that we have, yes, like enough data to carry out whatever that we want to do at the end of the day. All right. And the mean here tells us on normal days, how does a production looks like? So how does the conditions looks like, right? On the normal days, how does the conditions looks like? And standard deviation tells us the stability, yes, of the world, all right. And we have mean. Mean tells us that that's the least value that we could get, all right. And we have 20% percentile, right? So this one is trying to tell us that 20% of stream, yes, like hours fall below 20.89. Right. So that's the 25 percentile means, right? 20, 25 percent of times stream hours 2.89 falls below, right? And we have the same thing, 50 percentile, right? 50 of the times, sorry, that's like 50% of the time, we get 22.40 below stream hours, right? The same thing has to do with 75 and max, the maximum production or conditions that we do have, right? So all this statistics is very, yes, like important. The model needs all these things to understand the behavior, all right, so that yes, like it can make better predictions or decisions, right? And the third one has to do with EDA, right? We have to that's like explore the data, see what is going on, and how best we can tweak stuff to ensure that we feed right data to the model, right? So here we are going to see the production, yes, like overview, daily production, yes, like over time. Let me plot the graph so that we can take it from there. Okay, so this is some EDA that we do. Yes, like we do have or we do so that we see how the data looks like, what's going on, right? So this, as we can see, daily oil production over time, we can see the production was decreasing as this move on, right? So we can see there was decrease, there was decrease, there was decrease, there was decrease. We could and total yes, like oil produced by the world, right? So each world, right? So if from the graph, what we can see is well 15/9 had the best production, right? Followed by the next one, followed by the next one, right? So these are all some, yes, like exploratory data, yes, like analysis that you can do on your data so that you can derive best. So we can see oil versus gas production, the relationship between oil and gas, right? So we can see the production as, yes, like gas keep moving, oil to keep moving, all right? So the correlation is 0.758. That's positive. That's a positive, right? And yearly production by fruit type, right? So oil, gas, water, how does the production looks like yearly, right? So basically, these are some of yes, like analysis that you can make to to ensure that you have the best. This is our correlation. We are trying to see how each features they are correlated, how best they are correlated, right? So we can see from here, like oil had the best correlation, right? Yes, like oil and gas, they had the best correlation, right? So basically, they are related. If gas go high, that means yes, like oil too will go high, right? So we have all these plots to show us how uh, relationships looks like, right? Okay. So the next step has to do with this is the very what, yes, like important. All right. Yes. So you have to, yes, like engineer the data, right? The data that you have to, yes, like engineer it. Since we've done, yes, like a lot of, yes, like exploratory, yes, like analysis. So that's how to know which kind of features that we are going to need and which kind of features that we are not going to need, right? So when you come to the production of yes, like oil, pressure is very yes, like important, and we are going to need that, right? And and production declines too is very what yes, like important. Time is very yes, like important, right? So we need all these features, right, so that the model can at least learn what, right? So basically these are the like extra features that we are going to create, right? Days since that, right? So we need the days since we are predicting the production daily. We need the days feature, all right? So we are going to get the days feature, we are going to get pressure differences, right? We are going to get temperature differences, right? When that is done, production, we are going to get gas and yes, like oil ratio. That's very what yes, like important. We are going to get water cut. So these are the features that we are going to add to our data set because they are very what yes, like important to our production that we have to add it to the data so that our model can learn best, right? Okay. So now we've created all these features and we've added them to the data sets, right? So now model training, right? So when you comes to the model, now we've gotten our data, we've done some preparation, right? Now we are coming to do the training. Right. So the training, we have feature selection, right? Which kind of feature that like we are going to use. See, we have a lot of features, right? So we have to ensure that we are selecting the best features, right? This is where domain, yes, that's like expertise come in place, right? So you know that temperature is very what? Yes, like vital to production. You know, pressure is very vital to our production. All right. So you select all the features that you think like they are going to play a major role in the production. When that is done, we split the data into train tests, right? So the training set we use to train the a model and the test data we use to do what? Yes, like evaluate the model. After the training, we have to test it to see whether our model is doing good or bad. All right. Then after that, we get our train model and yes, like evaluate it. Right. So here, as we can see from here, we are selecting the features. So basically, this one is a supervised learning, right? So we have our, yes, like inputs. So these are going to be our what? Yes, like inputs and features. And this is going to be our what? Yes, like output feature because we are predicting daily production, right? Yes, like oil production. So this is going to be our target feature. All right. Okay. So now we have our what? Yes, like inputs features and outputs feature. Right. Okay. Then we split our data. As I said, we are going to split it into train tests, right? So we are taking, yes, like 80% of the data for training, and we are taking 20% of the data for testing. We define our models, right? Since we don't know the model that will give us best results, what we do is when you come to yes, like our place. That's the best way that we most of the time, yes, like handle this problem is we define all the models that we want to use, right? Since we don't know the one that will give us best result, we define all the what, yes, like models and train them all, right, to see which one will perform well. So basically, this is what we are doing here. We are taking our linear regression model. We are taking our ridge regression model. We are taking our lasso regression model. We are taking our decision tree model, random forest tree, gradient boosting, XGBoost, light DMN. Now, I know we all know much about all this model and how they work, right? So we are selecting all this model and train them, right? So this is where the training is going to take place, right? So model.fit. All right. So basically when a machine learning, yes, like engineer tells you that, yes, like he's training a model, what he's doing is, yes, like he's doing a model.fit. This is what, yes, like the guy is doing. Yes, like you are going to think that like he's doing something giddy giddy giddy. He's just doing model.fit. I'm lying. There's a lot of stuff that we do. But yes, like basically, this is what, yes, I will do the training. Model.fit. All right. So this model.fit, what we are doing is we are going through all these ESLA models and training them one by one, right? So the programming guys, those who are much into programming, you could see that, yes, like we are using a for loop, right? Yes, like we are looping through these models and selecting them one by one to do the training, right? Yes. So when that is done, yes, after the training, we are doing some calculation. We want to, yes, like that's like evaluate, yes, like each model to see the performance so that we can select the best model, right? And then a matrix that we are going to use is to yes, like R squared and root mean squared. All right. So we are going to use, yes, like R squared and root mean squared. All right. So R squared, how the a matrix works is, yes, like it tells us, yes, like how much behavior yes, like the model has learned. All right. So yes, like it will measure the the behavior that the model has learned, right? So if we are getting closer to one, that means the model has really learned well, right? But if we are getting something less than one, something below 0.5, that means the model, yes, like it's not learning, right? And root mean squared, yes, like error predicts, yes, the mistakes that the model, yes, like is doing, right? So if we are getting huge amounts, like huge root mean square, that means our model is making, yes, like that's like a lot of, yes, like errors, right? And if we are getting less root mean squared, that means our model is making less, yes, it's like mistakes, right? Okay, so basically that's what we are doing here. We are doing two things here. We are training them a model, and second, we are calculating their performance, right? And the calculation we are doing root mean squared error and, yes, like R squared. That's what we are doing. So we are training each one of the model. Okay, so now we are done, right? So what we do here is first we we ensure that we have score for the train set and also we have score for the test set, all right? So each one of them has to be balanced, all right? We don't want a situation that the training set is scoring high and the testing set, yes, like scoring low. So if we get that situation, that means our model is what, yes, that's like underfitting, right? But if we are getting training score high, test score high is what, yes, like overfitting. So we have to get something what, yes, like moderate. All right. So we have to at least when our training score is high, the test score is supposed to be high. All right, to be good. So here, as we can see, linear regression, the training score is 0.6, not bad. The test score is 0.6, not bad. The root mean square is 892, not bad, right? And when we check rates and regression, the R the training set we had 0.692. The test set, we have 0.684. Not bad. All right. Okay. So in all, we can see that we are getting, when we come down here, light GBM, the training set, we are getting 0.9. That's huge. And as I said, when we are getting, yes, like R squared to be closer to 1 or 1, that means, yes, like it's good, all right? But if we are getting less than 0.5, that means like it's bad. The training is bad, right? So as you can see here, the training sets give us 0.9. The R square is 0.9. That's good. That's great. The test is 0.85. That's great. All right. And the root mean squared error. The root mean squared error is less as compared to all of them. The light GMB is less as compared to all of them. So basically, based on this result, we can say that our light GBM performs better than all of them, right? So basically, yes, like if we are to select the model to use, we are going to go for light GBM model, right? So basically, this is the kind uh, for we of personally, this is how I do my training, right? So I select all them a model and train them all and give them score, right? Yes, that's like evaluate them and see the results and take the best one, right? So now I can see that the light GBM is giving us good scores, right? So now we will take this model, and if there's some fine tune that we have to do, we will focus on it and change the parameters, and we are good to go, right? So let's display the results. Is the same thing what we are having here. Like yes, like it's the same thing that I'm printing here. Right, right, yes. So this is how you can check the predictions. This is how you can get the scores and choose the best model to use, right? So from the table, we can see that our light GBM is performing well, right? So now we can all, yes, like agree that our best model here to use is light GBM, all right? Yes. So this is the light GBM. That's the model that we are going to use for our prediction. All right. Okay. So model comparison. This is we are just I was just doing comparison of the models, right? Graph. I like graphs, right? So graphs, you get to know what's happening visual, right? So we can see the scores, right? So each one of them, the train and the test, we can see from here, right? All the scores, right? Yes. So we've said all these things, but this is to visualize it, right? To have a feel. So basically, when you are presenting so when you come to, yes, yes, like industry, for instance, after we are done with our training, we have to present it or pitch to the bosses, right? To explain how things are moving, the scores, why are we making this decision, right? Yes. So this is to tell maybe yes, client or your boss or the supervisor, this is why we have to go for this model, right? Yes. It's just for presentation purpose and yes. So now that we've seen that light GBM is the best model, right? So now we can use these models to do predictions, right? So anytime that we have well conditions, we can use this model to make predictions, all right? So we have our test data set. Let's make some predictions on our data set, all right? Okay, so this is our test set, right? So the test set is basically the test set. What the test set does is the test set, the model has not seen the test data. Do you get it? We only trained it on the training data, right? So let's assume that you are going to write a test, right? So the the test that you are going to write, that's not what, yes, like you are going to learn, because you don't have any idea on the questions that you are going to get, right? So you just learn your books, right, to get something. At the end of the day, you go and sit in the hall and you get the test data, right? So basically, this is the test data. The test data, the model has never seen it before, right? And we are making prediction, right? So this is the test data. So as we can see, we have the actual, yes, like oil production and the predicted, right? And the prediction, yes, like error, right? So as we can see, the model predicted 105, but the actual production is 1435. Right. So the model was getting closer to, right? Yes. When we come to the next one, we have 1206, but the model predicted 2012. That means the model predicted high. All right, yes, like higher than the normal. All right. So we have the, yes, like actual production and the predicted production, right? So this is just a predictive values, right? So based on this predictive values, you can use this predictive values to make decisions. All right. Okay. So let's say today production will look like this. All right. So what are the steps that we have to put, yes, like that's like, yes, like in place to, yes, like ensure that we meet, yes, like everything. All right. So basically, that's how we train a model and use it for predictions. All right. Okay. So from that, basically, sometimes supervisors, yes, like clients, want to know why the model, yes, like is predicting this, yes, like this value for trust, right? So that they can trust the model, right? That's where what, yes, like explainable, like AI comes in place. But today we are not going to go into that, right? So it's I've make it comprehensive so that you can go through by yourself, right? But that's not needed. Then needed aspect is how we can use machine learning for predictive, yes, like analysis, right? And now we've seen how we can use machine learning, get our data, train it to make predictions, all right? So basically, this is whole of it, the case study, all right, from a perspective, from, yes, like industry standard, all right? So I will end it here. It seems there has been a much talking. It's like I will end here and take questions. If there are questions, I'll take them and address it. And let's see equality there or something. Yes.
Thank you so much, Malik, for this very insightful presentation. Um, when I first posted this flyer, I got a lot of comments from a lot of my colleagues saying that where did I get you from before I was supposed to moderate this meeting? And I also got people saying that you are their mentors. And after this presentation, I'm beginning to understand why there was that much of a reaction when I first sent out this the flyer and the proposal for this meeting. Thank you so much for this insightful presentation about data and also modeling. So if you have any questions, we would like to take them. Please drop them in your chat box, and I'll start. I'll start with some of the questions I have over here. So the first one I have is, what skills should someone start learning if they want to work in predictive analytics? You have started.
Okay.
Mr.
Can I go?
Yes, please.
Okay. That's yes, like interesting. And first, you have to know Python, right? You have to get a programming language, right? And when you come to the what, yes, like industry, for instance, we have a lot of programming languages, but the one that we use a lot, because as I said, Python is versatile, is good, all right. So you have to get a programming skills, specifically Python. All right. So basically, to me, if if you are yes, like if you get our programming skills, you are 99% done. Like 99.9% done, right? Yes, like other stuff, yes, like that's like has to do with you learning other stuffs like reading your books and stuffs, right? Because what, yes, like you have to understand is, let's say you are a petroleum, yes, like engineer, right? So if you're able to get predictive, yes, like analysis, you are the one that, yes, like you are going to make good use of it, right? So you have the domain, yes, like expertise, right? So I'm not going to tell you that you have to go and learn the domain or something of that sort. You already have the skills in domain. You are going to class 247 and you have that's the domain skills, right? So what you have to do is just know the programming skills. That's Python. Learn Python, know how to use NumPy, know how to use all the tools. Then you take the models one by one, try to do what is like understand how a random forest work, how decision tree work, all right? You are good to go. So it's two things. Learn programming skills and learn how the models work, all right? And you are good to go. You are good to go for the beginning aspect. But if you want to go into, yes, like advanced, like a large language model, building large language models, like how what we do here, you have to read our research papers, all right? Our research papers and know some of calculus, all right? So it's calculus research papers, all right? So when you come to the place I work, for instance, every Wednesday we discuss our research and papers, all right? It's very yes, like important. You have to read our research papers, understand them, right? So basically, these are the skills that you need to start some predictive analysis. And even if you want to go more, these are the skills, your programming skills, your research papers, calculus, and yes, like understanding the models. That's all you need. You already have the domain expert, so these are the stuff that you need.
So that's great. I have another one. Say is okay. Another question is there no is the rate of learning in machine learning models linear or exponential? I don't. Okay, so this is up to you to. Do you, Mr. Malik, do you understand this question? Is the rate of machine learning models linear or exponential?
Okay, so if I'm getting you right, we have models that are, yes, like linear, right? So linear, like regression is a, yes, like linear model. Rage, lasso, they are, yes, like linear. But we have, there's one model that, yes, like I didn't talk about, and they are what? Yes, like exponential. That's like logistic, like regression, right? So yes, like that's like it's type of the models, but that's one, yes, that's like it's not linear, right? So basically we have linear models, and we have what? Yes, like exponential one, and that's the, yes, like logistic, like regression.
Okay. So
I don't know
are
if
there,
that answers your question.
please, Mr. Jude Felix, does that fully answer your question? Okay, moving on to the next. What are some of the spaces where we can get beginner projects, considering if a person wants to start learning this predictive analysis? What are some of the beginner projects that you recommend?
Okay, so basically program as a course. So basically, yes, like I will recommend the program that, yes, like I took myself, yes, from, yes, like Andrew. There's this guy, Stanford lecturer, and he's co-founder of Coursera, right? So you have to take, yes, like his program. It's very good, right? So if you want to, yes, like understand the models, right, you have to take his program. When you go to YouTube, okay, I hope I can do this one. When you go to YouTube, this guy. Mm. Uh, Okay, yes. So I took this course from Coursera, right? But currently it's paid course, right? So for you to not for free programs, you have to take this course. It's very good. It gives you the basics, right? How the models work, how you can make prediction. And yes, like if you want to be a proper what, yes, like machine learning, you have to know how to build this model from scratch. And yes, like Andrew would teach you how to build each one of them from scratch, all right? Yes, like it's going to teach you how to build, yes, like linear regression from scratch. What we were doing here is we were just calling it from from a library, right? So if you want to know how to build it from scratch, you have to follow this guy, take his courses, and you are good to go, right?
Okay, so Professor Andrew from on
Yes.
YouTube, right? Good. We'll be taking us through machine learning. Okay, so I have another question from someone. He says, what percentage ratio should we split the data set for training and testing respectively?
Okay, that's a great question. So if you guys could recall, I said machine learning is an, yes, like iterative process, right? So yes, like I came here to run this notebook cells, just running. You are going to think that, yes, like I use a day to did everything or something of that sort, right? So all what I'm putting across is, though now currently the standard one, they are saying 80 training sets, split it 80, test set 20. But that's not the yardstick, right? So what you have to do is you have to be testing with the percentage, right? Let's say if if with the first training you splitted it 80-20, try with 90-10, right? To see yes, like how best the model will perform. Right. That's the goal here, is to get, yes, like a lot of training sets to train the model so that, yes, like it can learn from from the data. That's the pattern centering, right? So if you have, yes, like enough training data, then you can go 80-20. All right. But you have to be changing the values, right, to see which one performs best. All right. So everything that I did here, I did a fine tuning. All right. So let's take the our parameters. Let's take this one for instance, these models. All right. I was changing where's the model selection, the model training. Okay. So let's assume this one, right? So I was changing the parameters to see which one works best, right? So yes, like it's not that we don't have a standard. What yes, like you have to do is you have to be changing the parameters to see which one, yes, like is giving you good results. Please, are you good? Yes. But starting, you start with, yes, like 80-20, then you do fine tuning, changing the parameters to see which one works best.
Okay. Mr. Melik, I believe you've shared a data set, right? Did you do that in the chat box?
Okay,
Or
yes,
something?
okay, yes, this is the link to the data set. You have to
Okay.
go to Kaggle. Yes, let me copy. Oh, sorry. Let me copy. Oh, what am I doing? Did I copy? So this is the link to the data set. When you go, you have daily production data and monthly production data. So I chose daily production data. You just go and download it and you are good to go. Right. Yes. So I'm sharing the link to the chat so that you get the link.
Amazing, amazing. So, Mr. Melik, after this whole um conversation or this lecture about machine learning, what is one thing that the audience should take away from this whole session? If you didn't learn anything at all, and it was one thing that we are taking away, what should it be?
Okay. So what
What's
I would
one thing
say
we should
is,
take away? Yes, the key
yes,
takeaway.
the key takeaway is to see like machine learning as a precision tool, right? Yes, like in your, yes, like engineering toolkit, all right? So basically, machine learning is basically now changing lives, right? Everyone is trying to, when you go to every places, yes, like industries, yes, like everyone is trying to, yes, like adapt machine learning, yes, like in their, yes, like workflow to get best production, right? So I will, yes, like advise you to take machine learning as a precision tool, right? And add it to your, yes, like engineering toolbox, right? Whether you don't have to be a pro or something of that sort, know how to, yes, like apply it in your domain, right? So as we just did, know how to, yes, like apply it, yes, like in your domain, and you are good to go, right?
Amazing, amazing. So, are there any more questions? Do we have any concerns, suggestions, input? Oh, we are good. I believe at this stage you are good. Okay, so amazing presentation. And I want to give a few announcements, but before I do that, I want to acknowledge a few people who have Engineer Daniel Opong. I see he's with the career and guidance team. I appreciate you, Mr. Samuel J. I appreciate you. Afufwa is in Seattle. I appreciate you. And the person who also guided me through this whole moderation, I cannot leave you out, Mr. Osei Bonsu. I appreciate you so much for joining us. Mr. Atuedu, I appreciate you for making time to join us. And to the audience
Thanks.
also, your the time is very acknowledged. And also to Mr. Malik for dedicating your time and treasure, your talent to passing on this information to the next generation. Us appreciate you greatly. So just a few announcements. We're having another session of this sort next week, same time. To It's a continuation of this session, of this discussion. I'll urge you all to also take advantage of it, to make time and also learn from where we stopped off today. Moreover, there's GH buys, which is coming up in May. There's still time for the students to apply. And this is a biennial competition. It comes once every 2 years. So now that we are having it in 2026 until 2028 before it will come again. So I admonish the students to take advantage of it, and let's grow ourselves in that space. Any other? Okay. So I would like to urge all of us to also, those of us who are not part of the SPE space, who have not registered, want to use this opportunity to become a member so that you can have more access to the society and to the repository that has been made in store for you, to the papers and to the benefits, the numerous benefits that we have. This should not be something that you miss out on. So if you have not done that, I admonish you to join or renew, and also to become a professional member. After your student membership, become a professional member. You visit spe.org and sign in. If you are new, create an account, go to the membership section and select join or renew membership. You choose the professional membership option. The new professionals may complete the application form. Then existing members may review and update their information, pay the registration or renewal fee, USD 45 for new members and USD 35 for renewing. You receive confirmation once your application or renewal is complete. Then I believe the same process after registration, you log into your SPE member, you update your profile, then you also access some of the benefits we have over there. I believe the same process also goes for student membership as well. So if you're a student, take this opportunity to register and renew your membership. As I said, so the next upcoming event also we have part 2, which has to do with machine learning for probabilistic decision and adaptive risk analysis. Next week, we're going to look at machine learning. Do well to take advantage of it. And also we have future of energy, the future of energy conversation we'll be having is going to be focused on opportunities for young professionals in the changing industry. We want to stand by for this information. Immediately we drop the details, do well to add it to your calendar and then take advantage of it. And as I mentioned, Ghana Biennial International Summit and Exhibition. And this year's theme is Sustainable Energy for Africa, Powering Growth, Innovation and Inclusion. It's going to happen in Accra, May 20th to 22nd. Do all to apply. And also there is a pre-training, pre-exhibition training. Also, everyone is encouraged to take out, how do I call it? Take advantage of it. And once again, I want to thank you all for making it. Thank you so much, Mr. Malik, and also the organizers, facilitators, and everyone. And much love to our audience. Hope to see you next time. Let's do all to connect with ourselves on LinkedIn and grow in SPE. Look forward to seeing you next time in our future meetings. let's have some reactions before we take our leave. Few reactions. Let's have it. Let's have them. Let's have them. A few reactions before we take our leave.